Yeah. So good evening once again. So today's main topic is going to be to do some practical things in creating a database. And if you remember, we had one exercise where you were asked to do, an ER was given to you and you were asked to do the mapping, which means converting the ER into a form of a table. Now, assuming that those tables that we did together after the assignment, we have tried to do it together, that the tables are all correct. Today, what we are going to do is try to convert into a physical representation of those schema and try to develop the database using SQL Server 2014. So in the meantime, we'll try to see some of the things. So we'll try to build the whole database. Due to the time constraints, I'm not going to write everything on the query board. Rather, since I have already written the query, I'm going to copy and show you how things are done. Then, if possible, we'll try to see inserting some data. Last week, I asked you, to forward me if you have any question or anything that you want to be clarified during this practical session, but I have received only an inquiry from Haile Mariam, and the other one was from Kalab. With Kalab, we tried to communicate through Telegram, and I clarified some of the things, but there is also another thing that he asked, which we'll try to do today. Haile Mariam's case, after we develop the database, we'll try to see how such kind of things like inserting data into multiple tables can be done. So I'll try to do that in the meantime. So this is the plan that I have. I believe all of you are on board with this, right? Are you all on board with this? Huh?
Yes.
Okay. So I believe if there are no questions, then I'll directly move to.
Yes, right.
Okay, I'll directly move to the practical task. So I'll be sharing my SQL Server screen. As you can see, this is SQL Server 2014. So what I'm going to do is I'm going to create a new query board. Then I'll start to do the job. But before doing the practical thing, let me take you back to the mapping that we have. So let me share the word processor that we used last time. So as you can see, I believe you all can see the word processor document, right? If I have one confirmation, that would be enough. Can you see the document where we have the AR diagram?
Yeah, يتغير.
Okay.
Yeah, يتغير.
Okay.
Yeah, يتغير.
Thank you very much. So this was the AR diagram that we have, which tries to manage a project that are forwarded or that are contracted by a client or a client requesting a project, and every project is going to have a staff to manage it. And we also have a project having multiple tasks, and the tasks are being dependent to one another, which is a recursive relationship. And we also say the task will have a timesheet, and that timesheet is going to be submitted by the staff. So after we had this AR diagram, we tried to do the mapping by following the mapping rules of a relational data model. And as you can remember, we created each of the tables or the schema with the foreign key reference. So this was a table that we had. Now, the first thing that we have to do in this process is for each of the tables, because this is just at a schema level. This is just at the, at a schema level, which means it's at the logical design level, which cannot be directly converted to a computer instruction or understandable by the database management system software. So this was what we had last time. So the first thing that you have to do is try to come up with a physical design for each and every schema or for each and every relation that we have identified. So let's go back to the first two, and then we'll proceed as it is. So we have the client phone and the client table. So this was the two tables that I'm referring to, the client phone and the client table or schema. So what I've done is for each of the attributes of those relations, I try to come up with a data definition. I mean, deciding the data type and the constraint was the first thing that I've tried to do, okay? So that was what I was trying to do in here. So as you can see, for the first thing, a client phone, client ID is a primary key. The data type is defined to be character size of 4, and it's a foreign key. And the foreign key is from the client table, okay? But phone type and phone number are the new attributes that we have, which has character size of 20 and character size of 15. But we have said that client ID and phone type together, there would be a primary key. So what I've done is on the constraint part, I said client ID is a primary key and phone type is a primary key. So I'm trying to distinguish a telephone of a client by the phone type. Maybe we'll say client ID has a mobile, client ID has home phone, client ID has a phone, I mean an office phone. So at least we'll have 3 or any number of types. But the phone type is the other distinguishing factor or attribute that we have. So for the client phone table or relation, we try to have a data type and a constraint. For the client relation, as you can see, we also try to have the data type for each of them and the constraint. So in the client table, the only constraint that we have is client ID is a primary key, except that we set the data type for each of them. If you go to a project table or relation, project ID is a primary key, and we have all these non-primary key attributes. But in addition to that, in addition to these non-primary key attributes, as you can see, the data type is different. At one point, we have character size of 4 and 50. The other one is a float because I'm talking about a price. Then estimated start date, estimated finish date, start date and actual finish date are having a data type of date. Then I have current status as character size of 12. Then the duration is expressed in terms of integer. Then finally, we have 2 foreign keys here. So staff ID is brought to a project. So we said here at the constraint, it is a foreign key from the staff table. Client ID is brought from a client table as a foreign key. Mind you, in this process, make sure that the data type of the foreign key is identical with the data type of the primary key. So for example, in this case, a client, for a client attribute, it is a foreign key from the client table, which means the data type should be the same as, identical with the attribute in the client table. So if you go to the client table, it says character size of 4 here. Here also it says character size of 4. So make sure that the primary key and the foreign key would have exactly the same type of data type and size. Otherwise, the referential integrity, I mean, the referential integrity is not going to hold, because we know that referential integrity is concerned about, it is concerned about an attribute taken from one table and put in a separate table or in another table. So it is assumed that, or it is true that the 2 columns are of the same type. So you have to make sure that the data type of the primary key and the foreign key is one and the same. So in the project table, we have 3 constraints. Project ID is a primary key. Staff ID is a foreign key from the staff table, and client ID is a foreign key from the client table. So just by looking into the mapping, I try to create the data type and the constraint for each and every relation. For the staff table, it's only a staff ID, which is a primary key. For the task table, the primary key is task ID, but a project ID is brought as a foreign key from the project table. But mind you, I have given different data type for each of the attributes that we have in here. For the timesheet, the primary key is the timesheet ID. This is, by the way, exactly the same as the ER diagram as well as the mapping that we have done. So what I've done is just added this data type, and this is directly referred from the ER diagram or from the mapping. I didn't add anything new in here, but the decision is only on the data type and the size of the attributes or the columns. Now, this is the other interesting part that we have. If you remember, prerequisite task is a recursive relationship or a union relationship. So as you can see, task ID is character size of 6. So if you go to the task table, it is character size of 6. And the task ID is posted twice. As you can see, the foreign key refers to the same table. The foreign key refers to the same table. This shows you that we are referring to the same attribute in the task table. But at the same time, in addition to being a foreign key, they are also jointly, they would act as a primary key for this table or for this task prerequisite table. So this is the definition that we had. After we did this, now we can directly move into the actual database development or the actual coding. So let's go to SQL Server. If you have any question on this part, let me know. Do you have any question on the mapping? I mean, on the what we call on the physical design, the choice of a physical design that we have done. Do you have any question?
Should we care here about anomalies?
Yes.
Should you care here about anomalies?
Of course, we should.
Anomalies.
Of course. Do you see any anomalies in here? Mind you, the issue in here is if we do a correct mapping, as long as the ER diagram is correct, then we know that we don't suffer from data duplication. And if we don't have data duplication, our table will not suffer, or our database is not going to suffer from those three types of anomalies. Okay? Do you see any kind of anomaly?
Maybe the screen is different here.
Okay, let me go back to the physical design. Okay, which one are you referring to? Which table are you referring to? Huh? Are you with me? I'm trying to understand which table.
Yes.
Yeah, which table is the one no, you think would have anomaly?
If I want to add the stuff in different table from its parent staff employee ID, can I make it null or?
Why? Because a staff table is a single table. And as you can see, staff table has a staff ID, staff name, mobile, and job title.
Yes.
So where do you think would be, the anomaly?
The staff ID is also connected down to the other table, so that if I pass that.
Which table, for example?
Down there.
For example, here in the timesheet, the staff ID is attached as a foreign key.
This foreign key here.
Yeah, so it's not anomaly because it means that a single staff can be assigned or a single staff can submit multiple timesheets. In a foreign key, I have to remind you once again, when we discuss about a relational data model, we said a foreign key is not like a primary key. In a primary key, the value must be unique and it must be inserted only once. But in a foreign key, you can have multiple values of the same type. And it shows you that there is a multiple relationship. It's not a duplication. Because what you are going to put in here is just the ID of the staff. And this ID is referred from the staff table. You're not going to create a new staff ID, rather to refer whatever exists in the staff table. So in the timesheet, if you have the same staff ID 5 times, it doesn't mean that staff is duplicated. It means that that staff has submitted 5 timesheets. For the tasks that he performed, he submitted 5 timesheets. So for example, today he worked for 3 hours. Tomorrow, the day after yesterday, he worked for 1 hour. The day before that, he worked for 6 hours. So he's going to collect that and put it in a timesheet. And each of these timesheets will be associated to a single staff. Okay, Tedros? Okay. So if you don't have any question on this one, let's move to SQL Server. Do you have any question? Okay, I guess there is none. So let's move to SQL Server. I believe you all can see the query working area, right?
Yeah, right.
ይታያቸዋል አይደል? So the first
ይታያል።
thing that we are going to do is create the database, the repository for everything. So let's assume that this is a software company ብለን assume እናደርግ. So the first thing that you are supposed to do is create a database. So first let's switch it to master. Then after that, let's create the database. So this is a statement that we have. So we are going to use the simplest SQL command or script. So we say create database and we call it ABC Software Solutions. So before creating the tables, then we are supposed to create the repository, which is the database. Then we are going to execute this one. Okay. Let's see what we have in here. So create database, ABC Software Solutions. So when we come to a database, and as you can see here, what we have is the databases that we have so far is MyDB, CS552, HR, Shop, and Test. So when I refresh this one, the new database would be shown. As you can see, ABC Software Solutions is now a new database. And if you go inside and go to the tables, as you can see, we don't have any table because the repository or the database is now empty. Now we cannot, this is a code, I'm going to share the code with you. Now, after you create the database, you cannot directly start creating the tables. First, you have to switch your working directory. As you can see here, your working database, the active database that is being operational at this point is masters, which means whatever script that you write in here on the query working area is going to be performed under master. So the first thing that we have to do is change our database, the current database. And for that, we are going to use the command use. So we are going to use ABC Software Solutions, which means now the moment we execute this one, you will notice that the name here would change because we want to use ABC Software Solutions as the working database at this point. So then after that, we would execute it. Immediately, the working or the current working database is going to change. Now, anything that you do at, starting this point is going to be executed under, or it's going to be done, or it will take effect under the database, which is ABC Software Solutions, okay? Now, the first thing that you do in here is you have to look into your tables, okay? Here, you have to look into your tables. You have to make sure that a table with a foreign key should be created after its parent table is created, which means in this case, in our database or in our structure, let me take you back to the Word document. In here, you should note that the client phone table cannot be created before the client table because the client phone table has a foreign key, and this foreign key, as you can see, this foreign key is, it is pulled from the client table. So before creating the client table, you cannot create the client phone table. So generally what you do is a table with a foreign key should be created only after its parent table is created, okay? So as much as possible, create tables without constraints, up in the process, create them first. Then after that, move into the tables with a foreign key constraint. So this is what I have. For the first one, instead of creating the client table, I'm going to create the client table itself. So let me take you back to the client, to the SQL server. So the first thing that we are supposed to do in here is create the client table. And to create the client table, this is what we do. Create table is a basic SQL command that we have. Then we have, then we have client, okay? Because it's a client table that we have. Then we are going to open the bracket. Then we are going to list all the attributes based on the data type that we defined. So we are going to have client ID, okay? And we said it is character size of 4. Definition will ask kanal. Then this is, it's a primary key, okay? It's a primary key. If it is a primary key, by default, it is not null and its value will never repeat. Then the next one is client name. It's the second attribute that we have. We said the data type is character size of 50, okay? And we said this cannot have a value of null, okay? Then the third one is a street, and we said this is character size of 15, okay? Then we have suburb, which is again character size of 15 billion. You can set it to anything as you wish, it doesn't matter. Then we have state, which is character size of again 15. Then what do we have after that? Postcode, and we said this is character size of 5. Then finally we have client type, which is character size of 20 ብለን ነው define ያደረግነው. Mind you, after the last data type, you don't need a comma. A comma indicates or tells SQL parser that there will be another attribute coming, but since we don't have anything after this, you don't need to put anything here. So as you can see, what we have is, sorry, here it is client, CLIENT, ID, car size of 4, primary key. Then we have client name, character size of 50, street, suburb, state, postcode, postal code, and client type. So after this one, we can select this table and execute or run it ማለት ነው. So the moment you execute, if every script is correct or every syntax is correct, then it will say a command has been successfully completed. And we can go to the table and refresh. The moment we refresh, you can see that the client table is created. After it is created, you can check whether it has been created based on your requirement. You have to check, or you can check whether it has been created based on your specification. And to do that, you can go to the right-hand side to the Explorer, to the Object Explorer window. You can go to the Object Explorer window and go to tables and go to the table that you have created. Mind you, if you don't see the table, just right-click and say refresh. Then any new table, any update that has been done would be shown there. So what we do is we'll open the client table and it will show you the columns. Then when you expand the columns, you will see all the attributes. As you can see, client ID is a primary key, as we said in here. It is character size of 4. It is not null because it's a primary key. We have client name, which is character size of 15, which is not null. We have street, suburb, and state with character size of 15. And we have postal code with character size of 5, and client type was character size of 20, and that's it. So the table has been created. And to see the constraint, you can go to key. And if you go to key, it shows you that there is a primary key to the client table. And this key is a primary key that we have. Mind you, if you have foreign keys in here, it would have been shown as well in here. So the client table is created. Now let's move to the client phone table, okay? If you want to, you can remove this one because once it's created, you don't need the script. So let's go to the client phone table. So we'll say create table. The table name is client phone, okay? Client phone. Then we'll open our bracket and we'll close it later on. So what do we have in here? What we have is client ID is with character size of 4. Mind you, it's a foreign key, so we have to make sure that the data type is the same as the client ID in the client table. And we say this is not null because it cannot be empty as it is part of the primary key. Then we have phone type, phone type, which is character size of 20. Again, it cannot be null. Then what we have is phone number, which is character size of 15, and it cannot be null. Mind you, this is a basic table that we have. But now there are at least two constraints. The first thing is client ID does not belong to this table. It is a foreign key, okay? It is a foreign key that we brought from somewhere else. So what we have to do is we need to have a constraint. Now in this case, there is another way of creating a constraint, and it starts with the keyword constraint. The moment constraint ስትሉት SQL server will know that this is a constraint that you put. Then immediately after that, you have to give it a name. What is the name? The name of, I can say, you can give it any name. So I will say a foreign key from a client table envelope. So client ID is a foreign key ማለት ነው. So we call it, let's call it FK instead of FR ከምንለው FK. Client ID is a foreign key ያለን ነው. What is the name of the constraint? Foreign key ነው. By the way, you can give this name anything. ABCም ልትሉት ትችላላችሁ. It doesn't matter. But to make it understandable, we use FK client ID እንለዋለን. Make sure that it is one string, okay? You cannot have a space in here. So we say it's a foreign key. Which one is a foreign key? It is client ID. Client ID no foreign key ሆኖ ስለዚህ what we say is client ID is, so we have a constraint named FK client ID, which is a foreign key, and that foreign key is a client ID. And from where did we bring that client ID? That is a question we need to answer. From where did we get it? We get it from the client table, right? So it references, okay? It references from a client table. The attribute that it refers to is client ID. So let me elaborate this one. Client ID. So what we are saying in here is, I have a constraint called FK client ID, which is a foreign key. It is a foreign key, and that constraint is on the client ID attribute. And it refers to, on the client table, an attribute called client ID. እዚህ እንትን ላይ አያችሁት እዚህ ጋር ያለው client table ላይ ያለውን client ID refer እንደሚያደርግ እየጠቆምኩ ነው. It refers to this one ብለን. Now the special thing about a client phone table is the primary key cannot be client ID, because we know that a client has a multiple telephone. So the primary key is a client ID and a phone type together. So I'm going to have another constraint. So I'm going to say a constraint. This time it is a constraint for this table. ቴብላችን ምንድነው? A client phone የሚል table ነው. So I'm going to name it as a primary key for a client phone, and the constraint is primary key. Okay, sorry, primary key, and that primary key is a combination of these two. ሁለቱ ናቸው አይደል primary key ያልናቸው. So I'm going to copy it here, comma, then I'm going to copy this one and put it here. Okay, ስለዚህ ይሄን በማድረግ ምን እየነገርነው ነው? We are telling SQL server that this table has a composite primary key, which is composed of client ID and phone type አልነው ማለት ነው። በቃ that's all you need to do. So in this table we have two constraints. One is a foreign key that we brought from the client table, and the other one is client ID and phone type jointly forming the primary key ማለት ነው. So after you did that, we can actually run it. ችግር ካለበት ይነግረናል. run ስናደርገው it says it has been done successfully. So I'll come back to here and refresh it. As you can see, in addition to the client table, I also have the client phone አለኝ ማለት ነው. So the two tables have been created ማለት ነው. So this is how we are going to create the tables. And to save the time, I'm not going to type everything. I have already created the script for the rest of the tables. So this is what I'm going to have in here. Paste ላድርገውና ታዩታላችሁ. So share ስለማረጋችሁ በኋላ ታዩታላችሁ. Already the client and the client phone table has been created, and this is a table for a staff. So staff ID is a primary key, staff name, mobile, and job title. So I don't have any other constraints. On the project table, I have project ID with a primary key. I have project description. ሁሉም ይመጣና ግን I have two foreign keys. One is from a staff table, and the other one is from a client table, foreign key ናቸው. So staff ID is a foreign key that refers to staff ላይ staff ID የሚባለው. Then task table line, the same thing. Task table line, I have task ID as a primary key. Then I'm going to have project ID, which is a foreign key referring to PID from the project table. When it comes to the timesheet, I have timesheet ID, work, date, description, hours worked, billable, current status. And again, I have two foreign keys from task and staff. The last one that we have is the task prerequisite. This is a recursive relationship, mind you. So task ID አለን, pre-task ID አለን, but both of them are referring to the same attribute. አያችሁት? ሁለቱም አንድ ቦታ ላይ ነው refer የሚያደርጉት on the same table. That's why we say it is recursive. So I have two foreign keys, but both are brought from the task table. And finally, I have a constraint. A constraint is a primary key, but the primary key is the combination of these two. Task ID እና prerequisite task ID አንድ ላይ ሆነው they would be the foreign key ማለት ነው. So these are the tables that we have. Execute አደርገውና እናየዋለን. Execute ስናደርገው all the tables will be successfully created. እዚህ ጋር refresh ስንለው we are going to have all the tables. As you can see, I have the client table, client phone, project, staff, task prerequisite እና timesheet የሚባሉት ቴብሎች በሙሉ አሉኝ. Now, since we are left with only one time, let me show you something and we will rejoin the session. ይሄ የሰራሁት ነገር does it have the correct relationship ለሚለው I can go to the database ላይ ሄጄ database diagram ላይ ሄጄ show me the diagram of the database that I have created ማለት እችላለሁ. እዚህ ላይ double click አድርጌ new database diagram ብለነው we can see whether that diagram is correct. ስለዚህ ምን እናደርጋለን? I will add all the tables into the diagram. Mind you, I didn't touch any, or I didn't try to create any link between the tables using a drag and drop method, but we'll see what the result is. Make sure to rejoin the class if it is interrupted, okay? Okay. Now have a look at this diagram. አያችሁት diagram? This diagram is exactly as we have it in our class አይደለ? እዩት ለምሳሌ ይሄኛው this is the recursive one that we have. ራሱ በራሱ ሲሆን እዚህ ቴብል ላይ we have this two. A task is related with a project, okay? A task is related with a project, a timesheet is related with a staff is related with a project is